Hi students, welcome to my lecture on process and simulated training on process operator training. And before I start my lecture on direct and cascade control, and I want you people to start with my lecture one. Please don't jump into the lecture on directly because we are moving in a progressive way. Okay. Uh, Let us enter into the today's lecture on direct and cascade control. And what is the objective of direct and cascade controls? Direct controls are traditional feedback controls, and the cascade controls are a bit more, proficient ones. That means objective of the any controller is to reduce the disturbances. Cascade is such a traditionally advanced control is because it will react faster to the situation as compared to the normal controller. Okay, these cascade controller systems are used for the processes where dynamics are very slow. If the sensor is detecting the signal is very much poor, then for those kind of systems, so we have to go for the cascade systems. For example, a level control. How the level control does the job? It will detect the signal level. If there is disturbance happen, the level will change. Based on the level change, automatically the control will take the action either by increasing the wall or decreasing the wall. Imagine disturbance has occurred. If you remember, in process industries, the tank is very huge example. Okay, there is some flow that has entered into the tank, more flow. Okay, but even though there is increase in flow that has occurred in the tank level will not rise because disturbance is small compared to the tank size. If that is the case, a tank will take it time to detect how much amount of flow that has come in, so that it will react in sensing, then it will send a signal to the controller, thereby it will control the value. So it takes time. That means it's a kind of lazy operations. For these kind of systems, we have to go for cascade operations. Instead of not just measuring level of the tank as an indicator, we have to measure the exit flow. What happens? There is a tank in the system. Okay, it has two sensors. One is exit flow sensor, one is tank exit flow at the bottom, one is a tank level. So it is easy to measure the changes in the flow rate than the changes in the tank level, because flow will react faster as compared to the tank level, because tank is very big in nature. It takes time to for the changes that to happen, the increase in the level of the tank. But imagine you are measuring the exit flow at the bottom. Even the small disturbance has came into the tank, the flow will be happen very faster. Before tanks actually show the reaction, the flow increase in flow is going to take place. So it is better not just to measure the only sensor that will measure the level. It is also important for us to measure the flow also. These are two sensors that comes in play as far as cascade system is concerned. Today we are going to learn one side you are going to see only direct control, and second one is a cascade control. Let us see which one is reacting faster to the situations. Let us go to the simulator mode. Okay. This is how before we go into the system, it takes time for this present lecture because it is important. There is two tanks. One is the left side of the screen is representing simple direct control, that means feedback control, and the right side it is called cascade control. And if you observe, the objective of this entire is to maintain the level in the tank at 50%. Here also maintaining the level at 50%. Okay, in this left side of the screen, it's called a direct control. Okay, what happens? Here there is a sense, because if there is some disturbance happen to this particular tank, what happens? The level is going to increase or decrease. Depending upon increase or decrease, it will detect a changes in the level. Thereby this controller will send a signal to either open a wall or close a wall. This is a direct control. Let us come to the right side. Okay, there are two sensors now. One is leveling the measuring the sensor which is measuring the level, and second another sensor is measuring the flow rate. Okay, the one which is at the top side is called, which is connected to the first sensor, is called primary control. The one which is at the bottom is called secondary control. That means it's cascaded. From the tags itself you will understand the second controller. If you see this kind of symbol, that means it is cascaded. That means it is controlled by the primary controller. The other name for the primary and secondary are master controller and the slave controller. Okay, let us not worry about the master and the slave. It's a primary controller, it's a secondary controller. The symbol C represents, it is the secondary controller is controlled by the primary controller. Okay, what is there? Okay, imagine, as I told you, the flow in a pipe will be much faster dynamics. That means time, it's increasing flow, decreasing flow takes place very fast as compared to the increase in level, decreasing level. So for those kind of systems, I wanted to precisely control the smallest disturbance that came into the tank. For those kind of systems, I will go for the cascade control systems. I have two sensors. One is a level control sensor. Second is a flow control sensor. Okay. Let us see what is there in the primary control. In primary control, the set point is 50. Okay, that means I have to maintain this set point. Present process value is also 50. There is no control action at this moment. Accordingly, it will send a signal, because according to the process value, it will send a signal to the secondary controller. You see, now here is one more set point, 250 meter cube per hour. I can able to set, because I cannot control any set points in the secondary controller. I can only control the set points in the primary control. The moment I change 50 to 60, automatically, accordingly, what flow should be there at the valve is decided by primary control. Let us example, there is some disturbance happened. The level has increased to 50 to 60. That means it will send a signal to the secondary controller. Okay, tank level has been raised. Now you change your set points. Okay, why this is? Because it will easy to control with the flow. That means the secondary control, what it will do, it will immediately react to the flow and it will control, because secondary controller will be connected directly to the valve which will sense the flow. But the set point for the secondary controller will be given by the primary controller. That is why it's called master control and the slave control. Imagine what happens. What I do, I hope you understand. There is cascade control, these two sensors. One is a primary sensor which will detect the level in the tank. Because the level dynamics are very slow compared to the flow dynamics. Okay, I'll show you. Once I go to level dynamics are slow compared to the flow dynamics. Now it will give a signal. It will only, the primary controller, what it does, it will decide the set point for the secondary controller. Now the set point for the secondary controller is 250 meter cube per hour. As long as the flow is 250 meter cube per hour, it won't take any action. They manipulate, that is 50% open. The moment the disturbance has occurred into the tank, suddenly the sensor will sense. Okay, this level sensor will sense and it will send some signal to the secondary controller. That means the set points for the secondary controller will change, and because of change in the set points in the secondary controller, it will immediately react to the situation. Okay, let us do the job. Whatever we are going to do now, there is a disturbance I am going to give through hand indicating counter. That means I'll open this valve. The disturbance will go to both the controllers. One is the direct control, second is the cascade control. Let us see which one react faster. Is it a direct control? It is simply one sensing element which will control the valve. Second is a cascade control. Let us open the valve for a moment. Observe. What is the objective? Objective is to maintain this 50% level in the tank. The moment I open this valve, the disturbance goes into both the tank, and see which one comes to the steady state faster. Okay, I'll open it. Let me open the controllers, put it aside. This is LIC 001. I'll put it here because for you to observe the set points and everything, and 002 set points here. Okay, FIC 001. This is the these right side, right hand of the screen indicating how the things are getting changed. Okay, now you can observe the moment I change something, how it will react to situation. Let me start the process. Now let me open this valve 50 to set value. Now it is manipulatable 50. Now let me give you some 70. Okay, now opening the valve. Okay, now see how the things will get reacted. Okay, observe what is happening. The tank level is getting raised in both the cases because I have opening the valve, because disturbance goes to the both the direct control system and the cascade control system. And observe the dynamics. What is the objective? Is to maintain this level at the same point. One is through direct control, second is through cascade systems. Now you observe which one react faster to the situations. Okay, meanwhile you observe the set values are getting changed here, because you cannot decide the set value for the secondary controller. Only primary controller will decide the set point for the secondary controller. Okay, because the process value is getting changed, accordingly it will give indication to the set value. So it will open, the secondary controller will connected to the valve, which will decide the flow. Okay, let me a bit faster. Okay, or if you want me to hold on, I will hold on for this video to make sure that I want you people to observe the things. Okay, let me things a bit small faster. Okay, otherwise it will take time. 5 times. Okay. Observe both the levels in the tanks. See the reactions. .68, 50.6667. Let us see how much it is going, because in industry, any disturbance, to control the disturbance takes time. Don't worry, but we cannot control the things within a second. No, we have to patiently observe. There is alarm. Don't worry about this alarm, because there is something beyond the level that is happening. The alarm, if you want to see the alarm, see what are the things are there. Yellow, that means there is some deviation. LIC 001 means there is some deviation that is happening. Okay, if you wanted to go to the trend window, I can show you the, before I go to trend window, let us take some time. See, it is going to higher levels, 51.57, 51.38. You can see the second cascade control is reacting faster, so that the tank level is not that much raised as compared to the direct control systems. And you can see the reaction, every reaction. If you wanted to keep, I will keep it here. I don't know. Okay. Set values and manipulated variables. Okay, LIC 002. I'll keep it on the right side. FIC 001. I want you to how the primary controller is controlling the secondary controller, which is cascaded to the primary controller. That is what the whole objective. Okay. It is almost, it has started. Okay, you can see it is always went to 52.33. Now it is went to 51. See, the control process is good for the cascade systems. If you want me to fast forward a bit, I will do it. Okay, 10 times faster. Okay, see the things reacting. Now the flow in this pipe is 305. Now flow in this pipe, you can say 308 here. What is the flow in this pipe? I mean, in this exit pipe to the tank is around 350. That means it reacting faster. It will trying to send more flow out as compared to this one. That means the reaction. Yes, sir. Okay, it is already went to 53.0. You observe this. The tank level kept rising because the dynamics are slow. It is lazy for it to detect the changes in the level and send the signal here. It is simple. Flow dynamics are very fast, so the reaction is also very fast with the secondary controller. Only thing that primary controller does is set the set points of secondary controller. What is the set point of secondary controller at the present moment? 398. It's a dynamically changing, because This is a process value is also dynamically changing. So accordingly, the set value of the secondary control will be decided by the primary control, not by me. Okay. Only I can able to set the set point of the primary control. If I wanted to maintain 51, I can put 51 here. It is, I cannot put in my set point in the secondary controller. And now you can imagine, see, now it is started reducing. 51.27, 51.262423, here to 52.98, 97, 96. Compare. You can see it is very important. Maybe it looks like it is both are slow visually, but imagine some kind of reaction that is happening inside the reactor, and it can, if it produces more amount of heat for the smallest increase in the quantity, then it is not advisable to even go for this direct control. It is always advisable to go for a bit advanced, traditionally advanced. Why I am using the word traditionally advanced? Because these days Cascade systems these are also old ones. It's not a very new one. It's a new technology has come in. For the BTech level, it is fine as such, because the Cascade controllers are traditionally advanced controllers, not in the present controllers. Okay, now you can imagine which one is reacting. See, this is the one that is coming faster to the situations as compared to this one. Okay, if you want to see me show the trend window, this is how the trend window looks like. Let me okay. The one which is coming faster, that means you can observe here what are the trends I wanted to show. You can see this is the set point. Okay, the bottom one is the set point. Okay, and the one next to it is the one is the bottom horizontal line is our set point, which I have to maintain at a 50% level. The one next to it is for the cascade control. That means even though the disturbance has occurred, it has reduced. Okay, the one next to it is called direct control. Direct control, it is taking some time to react, so that is why it is not yet controlled. The other two lines, these two lines indicating this one. Which one is higher is a flow, exit flows from the tank. The 4 represents exit flow from the cascade control systems. I mean to say, you can observe here what is the FIC 001. Just make a note of it. What is FIC 001? So accordingly, you want to know what is FIC 001. FIC 001 is this one, process value. Okay, the one which is reacting faster, which is the cascade control. So accordingly, if I go to the trend window, this is the cascade control operations. Okay, it is trying to move, exit, increase the flow because of the disturbance that has occurred. Okay, okay, this is how we have to go for the different control systems, and these are the trend windows will help us to figure out how much time it takes for the system to react. Let us say I have started the simulation is around 14-16. After 20 minutes, it takes around 15 minutes. So still 15 to 20 minutes for the tank to react. This is the real scale operation. It's not even though I have ended my lecture within 15 minutes, and because I have made the things a bit fast for it in the simulation, so it almost take 20 to 30 minutes for the system to stabilize itself. And you can see there are some fluctuations that are happening, because always the control process is going to match with it of a 1 second, let me come back to this. Because there are fluctuations in the trends, because it always tries to match with the set point. Initially, sometimes go upward, sometimes it go downward, upward. So finally, it will reach to the steady state. Okay, this is as far as cascade and direct operations are concerned. Hope you have learned something. Visually, graphically, because a video will give you much better explanation compared to the hand calculations we do in the class as far as the PDC is concerned. Thank you, and this is Dr. Surendra signing off.